afternoon, everyone. Thank you very much, especially to our friends at ROS-Industrial Consortium, Asia Pacific. Very thankful and very honored that being invited to share about Delta Research Center's work and what we do offer to our partners in the ecosystem. So today our topic is definitely on our work that we have done for automation in manufacturing, and especially in the area that is reconfigurable and flexible. So let me begin with introduction of Delta Group. Next slide, please. So first, Delta has been manufacturer for more than 40 years. So what you do see on the screen right now are various diverse products that are being manufactured in our factory plants spread across the world, from China, India, Thailand, Europe, and US. Delta started as an OEM manufacturer. So the main product will be on power electronics. So you do see that from small components to embedded power, from thermal management, automotive electronics, for example, for electric vehicle, motor drive, power storage for electric vehicles, and also towards consumer products on power. There are subsidiary companies, Vigitech and Energy, that perhaps you have seen the products in the retail store for travel adapter, travel storage, battery pack. So these are products that are being manufactured in Delta Group and the products that we offer. At the same time, there is a business group that will be working on and serving the customer in the area of automation. So today's topic, I think, is related to this industrial automation, building automation. And towards Industry 4.0, we understand that there will be more convergence, not only in the factory shop floor, but in terms of the facilities and beyond that. So our business group that work on this area, automation, offer a variety of solutions in this. The third part of this is on the infrastructure. In our factory plant also, we produce different type of info communication technology, products that is for data center, for energy, renewable, solar panel, wind turbine, storage of energy, and so on. All these are the Delta Group that has been working on, and moving forward, we are looking at a focus area that is more towards green solution. I think this is one of it that is very important for the whole world right now as we look at the climate change. So whether we want to do more industrial automation, building automation, data center, and other area, the green, optimizing the energy efficiency, putting in zero net energy, all these are also very important. So in terms of this area, later on as I present on the topic on our reconfigurable, flexible manufacturing, one of the critical essential part will be also based on this green that is important for the factory. So for our Delta Research Center, next slide, our focus will be my role as well to build up technology capability, technology that is relevant to our business group, and towards the Delta transformation, what we are working on are towards more service and solution offering. So to work out a full solution from end to end, there are a lot of partnerships that we need to put together, solution integration, and in terms of solution, there are a lot of targeted specific offering that we need to carve out and design for our client. So the main thing is that as a base, what we are working on are definitely cyber physical system. So towards this manufacturing, what do we want to do better or advance even more for the manufacturing? So let me share more from our perspective. So we do see a rise in the manufacturing on demand. What is that about? Next slide. In the manufacturing on demand, we do see that a lot of the product that is being ordered has a high variant from the design, the model, perhaps even in different type of specification, in terms of all this. So it is not only the high mix that we do see in low volume, but high mix and high volume as well. A lot of the customization are needed by our customer. Across the world also there will be different level. At the same time, we do see trade war happening, and also the COVID-19 has disrupted supply chain, and we do see that the globalization has pushed towards more local production for local market. And this network of manufacturer around the world, how can we coordinate with one another and do better in this area? And the third one, we are looking at also sustainable development of product. Not only the product itself, but the process of manufacturing the product, that is the process that is well optimized and sustainable. So this is also a key that is area that for our Delta mission to be green and sustainable. Put together all the other rising technology or well-spread technology of digitalization, AI, and Internet of Everything. So with all this as the backdrop and motivation, we are moving forward towards on-demand manufacturing. But how can we do that? Next slide. So first of all, we do take, for example, the conventional production line. When it's being set up for automation, we do see that the machines are being introduced in a well-designed manner based on the product. For example, manufacturing of a single electronic device product, may it be mobile phone or laptop, there are multiple steps from perhaps 50 to 150 steps of the processing. So we have different type of machines being put in place, and the whole line of production, because to optimize the production, we have to figure out what will be the reconfiguration, what will be the best optimized layout. So when the whole line are being set up, the cost will definitely be very high, because you also need to include in the calibration, the maintenance. And once the product are being produced, most of the time we do not touch the production line. But once we have a high variety of products in being manufactured and the product life cycle being shortened, the production line need to reconfigure or being changed quickly. So in the whole life cycle of the machine, we do see a lot of this machine, when the line changeover, the method are being used as, you move up those machines that are not being used and put in add-on or replace with other machine. So machine or automation becomes even higher cost when we have a lot of line changing. So how do we do that? So here I'd like to share with you more how we come build up our transformable intelligent machine to address that. So we started off as for the electronic assembly process. In the electronic assembly process, you do see that being listed on the screen here. Typically after the service mount technologies, SMT or PCB board, there are still odd shape, odd size component that you need to insert in the PCB board. So you need auto insertion of this electronic component. And once it's done, you also need soldering. Soldering can be laser soldering or can be tip-based soldering. Once you complete the PCB board, you put in a case, different type of cases, and that is the assembly process where you encase it, and then you glue it up, dispensing the glue around it, encase it further, and then put in the screw and complete the whole screw driving process. In between of these steps, also you add in automated optical inspection for quality assurance. So you can also add in automated optical inspection machine, AOI, perhaps at the insertion before, after, or after soldering or after assembly, to make sure that the quality is up to the standard. So for each product, the arrangement of this different type of machine will be different, because the design of the product, perhaps one has 6 screws to be screwed in, the other have 24. So how do you optimize the production line with different machines? For example, for product A, you have 5 screw driving, 2 laser soldering. But for product B, you have the other way around because of the different design. But how do we have all these machines being able to switch and change from one form to another? Let me share further with you. Next slide. So the key component for this transformable intelligent machine will be the intelligent part of it, the software, the programming, the data implementation, that will help us to change the format of the machine, as well to optimize performance, because you have data collected, you analyze it, you know what is the best parameter to run for different product and processes. And each of it is modularized. For the software and hardware component is modularized so that the key system units can be reused for all the machines that we mentioned just now. And we standardize all the interface between different components, different parts of it, so that we can quickly mix and match and fix them up, configure it, optimize it, and run it, so that this changeover time will be very short. So put together all this, what we do see is, next slide, will be a TIM machine that has a modularized standardized design and want to facilitate the changeover of new processes in the production line much faster. And here you do see a photo of a screw driving machine, and it has all the key features needed for the on-demand line reconstruction and construction, and includes all the software related. So let me delve deeper into this. Let's go deeper in the next slide. So the key component of this will be definitely break into these three areas. What you do see on this first part will be the robot arm. It can be articulated robot arm, SCADA robot arm, it can be from different brands. And the end effector that we have established today are for electronic assembly. So you do see screw driving, gluing, gripper, camera, laser soldering, and along this functional performance. The second component are the common part that will be reused and being used as a standard frame and electrical control box. This will be a modular design, moreover lightweight, to make the reconfigurable line change easy. And we have the third component, which is the PC-based control system that we set up the drag and drop graphic control compatible with different robot controllers and end effectors. And to set up the whole system, able to run it, test it, we also have different type of data management, and it is evolvable and we'll add on along the way. So this is the idea of this TIM with these three major components. So let me go into a few examples how we built it. Let's go into the next slide. So in terms of a screw driving TIM, screw driving, we have the arms that is used here, can be SCADA or the 6-axis robot arm. Either one will be able to perform the function that we need for the screw driving. Depending on the product that you want to manufacture, you might need the 6-axis because of different angle. Otherwise, if it's from the top, you will use the SCADA. And the screw driving module and effector is the Delta product. And we have the standardized frame and e-box that we use, and we put in the camera and PC control system. Once it is set up, the whole TIM will function as a screw driving machine. And when we do need an automated optical inspection machine, we can use the common part of this to transform it to the other function. So next slide. Keeping the robot arm, standardized frame and e-box and PC-based control system, the additional replacement the end effector screw driving will be changed to the optical module industrial camera. So physically, you only need to change the end effector for the function, and it's not at the whole system level. Also at the same time, a lot of integration of the full system are done by system integrator, and to guarantee the full functionality, the performance, many times a replacement or change of the end effector are not encouraged. Even there are work done in this way, there are a longer time taken to tune it, to reprogram it. However, using our method here, we can change it much faster, as well as deploying new intelligent module. So for the AOI, we also have the DIVA module, which is a Delta Intelligent Video Analytics module, which is based on deep learning. It can perform auto defect classification for various electronic products. Moving forward, it can be trained and used for other type of product as well. If if you are keen to look at. So here, the machine learning AI component implemented in the machine itself will enable this fast changing of the module with the programming and the intelligence needed. So in other words, screwdriving machine can be transformed into AOI with both the physical side and the programming and intelligence being done rapidly. Okay, so next slide. So what we do expect by doing this is we want to make the reconfigurability of machine in the production line agile, fast changeover, and lower down the technical barrier, especially just as I mentioned, the programming usually are done by system integrator, but with our platform, there will be a library made available, and also welcome system integrator to add on a library component module, and we can share it with one another. And also for the third part of it, not only from a single machine, because as the utilization for different type of processing will be shared out, the data collected, we are able to perform analytics at the system level and extracting it up at the production line level, making the full production line analytics that are able to optimize for the quality and productivity. So this is the expected benefit of using the Transformable intelligent machine. And one of the focus part that we are looking at is the standard machine frame. Next slide. Within this, there are what we work on that we're also very thankful for ROS. We also use ROS in this control system and add on some of the functionality. And moving forward, also welcome different partners to come in to expand the multi-brand compatibility, so that we can interface with different brand, may it be the end effector or the other type of robot arm. So with all these, we are expecting evolvable models of the data and other types of analytics. Here we mentioned to you is more on the image side. Okay, so the standard machine frame, next slide, something that we are open to the partners that if you are keen to partner with us to utilize the standardized machine frame to speed up and allow the reconfigurable, this standard machine frame with the one connector that we provide, it will be easy to connect up machine to machine and between machine or inside one machine. The one connector also provide not only the power line, the comms line, the air and vacuum, all the necessary connection. Standardizing it, making sure that it is easily interfacing with one another. So with this standard machine frame, robot machine frame and functional machine frame, it will be the base where you can use it with the programming inside in the PC control box. Put up with different robot arm and end effector, perhaps to look into different applications in other segment, not only electronic assembly. So this is one that we welcome partners to discuss with us. So the next one, next slide, that moving forward also has in progress working on using ROS support to build different type of function from digital twin simulation, big data analytics, machine vision, safety purpose. So all these are currently made available to some of our beta version. Okay, so with that, I'd like to also go into the a very important part of the material transportation very quickly. Next slide, because as we know that production line as we can change over, but at the same time the material movement in the line today are based on conveyor belt, which is fixed or tightly coupled. Okay, we also make available a modularized conveyor, but I will skip to the part where we are emphasizing for today's topic for the autonomous mobile robot. So for this autonomous mobile robot, similar concepts are being implemented, that it has all the components able to fix up for different usage. You have the AGV as the base, you have the machine frame, you have the robot arm. Depending on your need, we can mix and match, we can deploy quickly, we can reduce the training operation cost. You can use it for not only manufacturing, healthcare, hospitality, so depending on the need. So for this, we are in pilot run to try out different segments as well. So putting this together, next slide, we understand that the whole material and logistics solution will be so important topic in the manufacturing, intra-logistic, how material movement are being carried out. So just implement an EGV or AMR will not be able to solve the problem. You need to look at it at a system level optimization. So we do look at the whole consultancy, how to scope out or area where the whole implementation are able to resolve and optimize the performance of the material movement in the factory. Okay, so what it all is the end-to-end solution here for the autonomous mobile robot and material transport. Okay, let me conclude it by giving a quick summary. So in order to achieve this reconfigurable production line, we have built a transformer intelligent machine and welcome partners to talk to us as well, discuss with us on this way to join us in this work that we can, from electronic assembly process, different function of DIM machine, and AMR, we can make the production line flexible and reconfigurable. All right, thank you very much.